Hi everyone, welcome to my YouTube channel. Now let me introduce myself. Jhansi Reddy S, USN 1VE 20CS055. Semester 6th CSC Computer Science and Engineering. Currently pursuing my education in Sri Venkateshwara College of Engineering. Now we are discussing about the subject non-conventional energy resources, and let us discuss about the topic solar photovoltaic system with its applications. Now let us go through some of the contents in the solar voltaic photo effect. Solar array, cabling, mounting systems, solar trackers, solar inverters, change controllers and battery. Now let us go through the photovoltaic system deep concept. A photovoltaic system, also known as the photovoltaic power system, solar PV system or casually solar array is a power system designed to supply usable solar power by means of photovoltaics. Photovoltaics is a method of converting the solar energy into direct current electricity using semiconducting materials that exhibit the photovoltaic effect. A photovoltaic system employs solar panels composed of a number of solar cells to supply usable solar power. Power is generation of solar PV has long been seen as a clean, sustainable energy technology which draws up the planet's most plentiful and widely distributed renewable energy source, the sun. Now let us go through some of the concepts like tracking. Fixed or tracking array. The PV array may either be fixed, the sun tracking with one axis of rotation, or sun tracking with two axes of rotation. The default value is a fixed PV array. PV array tilt angle is 0 degree to 90 degree. For a fixed PV array, the tilt angle is the angle from horizontal of the inclination of the PV array, 0 degree horizontal, 90 degree vertical. For a sun tracking PV array with one axis of rotation, the tilt angle is the angle from horizontal of the inclination of the tracking axis. The tilt angle is not applicable for sun tracking PV arrays with two axes of rotation. The default value is a tilt angle which is equal to the station's latitude. This normally maximizes manual energy production. Increasing the tilt angle favors energy production in the winter, while decreasing the tilt angle favors energy production in the summer. Now let us go through the PV technology and classification. Here in technology we use two type of technologies like thin film technology and silicon film technology. In silicon film technology we use monocrystalline, polycrystalline. Two types of use, monocrystalline and polycrystalline. Here we are going to discuss about the thin film technology. In thin film technology, the silicon deposited in a continuous on a base material such as glass, metal or polymer. The efficiency ranges from 5% to 13%. Thin film crystalline solar cells consist of layer which is about 10 μm thick compared with 200 to 300 μm layer for crystalline silicon cells, and also the pros low cost substrate and fabrication process, and also the cons, and not it is not very stable. Now let us discuss about the silicon crystalline technology. Here it currently makes up 86% of PV market. It is very stable with module efficiencies 10 to 16%, like monocrystalline and polycrystalline It is a second technology as monocrystalline Si cells, polycrystalline PV cells. In monocrystalline, conversion efficiency of this type of cells ranges from 13% to 17% and can generally be said to be in a wide commercial use. It is in a commercial use which is running in a current market. In a good light condition, it is the most effective photovoltaic cell. Monocrystalline Si cells are the most effective photovoltaic cells in the current situation or the current market. Now, let us discuss about the polycrystalline PV cells. The production of these cells is economically more effective compared to the monocrystalline. The efficiency ranges from 10 to 14%. The production like in the polycrystalline is more effective compared to the monocrystalline, because in monocrystalline ranges from 13% to 17%, but in the polycrystalline it ranges from 10% to 14%. Now let us discuss about the working of solar cells. Photovoltaic cells are made up of at least two semiconductor layers. It is made up of two semiconductor layers, one layer containing the positive charge and the other is the negative charge. There are two types of charges like positive and negative over here. Sunlight consists of little particles of solar energy called photons. What are photons? It is a little particles which comes from the sunlight. As a PV cell is exposed to the sunlight, many of the photons are reflected, passed right through or absorbed by the solar cells. When enough photons are absorbed by the negative layer of the photovoltaic cell, as two layers, as the photons when it is absorbed by the negative layer of the photovoltaic cell, the electrons are freed up from the negative semiconductor materials. As the photons are absorbed by the negative photovoltaic effect, the electrons will be released from the negative semiconductor material. Due to the manufacturing process of the positive layer, these freed electrons naturally migrate to the positive layer, creating the voltage differential similar to the household battery. When the two layers are connected to an external load, when the two layers like two semiconductor layers are there, right? When these two layers are connected to when two connected to an external load, these electrons flow through the circuit creating the electricity. This creates the electricity. E each individual solar energy cell produces 1 to 2 watts. To increase power outputs, cells are combined in a weather tight package called a solar module. These module means from 1 to 7,000 it's there, right? These modules are then wired up in a serial and or parallel, both are same with the another, into what's called a solar array to create the desired voltage and the amperage output required by the given project. Thank you for watching the video.